Thanks for joining. The first talk in the morning, it's always critical, I would say, to start. So, yeah, we will talk about how document parsing, and especially PDFs, affects retrieval-augmented generations. So, we are coming from a company called One of Tech that is giving consultancy on knowledge management, which, yeah, it's kind of a buzzword itself, but in this context means helping organizations retrieve and handling documents. And so retrieval-augmented generation is a technique recently discovered due to the use of the LLMs to enable users to retrieve documents in a different way. In this case, using natural language and the power of the LLM to condense a response. We see benchmarks and techniques to score how the later part, so how the response can be made, how the prompts affect the response, how to identify relevant documents from the perspective of the user query. But we are not seeing so much about the first part. So what's happening between the document base and the integration in the vector search. So how the document structure, how the document content affects what the developers will put in the vector database to allow the users to retrieve the passages or the documents or whatever they need from the original document base. Let's quickly zoom in on the first part. So it's not just about getting the text. We have PDF. We do parsing, usually. So we extract the text from it. We then split it in some ways using different approaches so that we have smaller chunks in the vector database so we can then retrieve the best part of the document that will answer the question of the user, or better to say that it's relevant for the user. But yeah, the PDF, it's a bit a hard format. So yeah, when talking about printing, it totally makes sense because it's well connected to how documents are printed. But yeah, the users actually started to think about the layout, so they made very pretty PDFs with complex styles, 2 columns, bubbles floating around, and so on. Also, users tend to include lots of complex tables, as documents might come from structured information that the users need to report to the management, for example, of the company, or to present somewhere else. And obviously, multi-column documents are quite hard on the reading order, as they are not exactly, all columns are not in line, so we need to jump in the vertical space. And additionally, we have headers and footers that are very relevant for the user to know where in the document you are placed and you are located, but might have an effect on the retrieval perspective in a RAG application. Yeah, so far I told we know more or less about how to test and evaluate retrieval-augmented generation. So there are different techniques to score. So we create a Q&A dataset. We evaluate the retrieval part. There are different scoring mechanisms, like using LLM as a judge for evaluating the quality of the answer. But what about the first part? So let's flip it, and let's consider using the same techniques as evaluating the answer, but changing what's in the first part of the pipeline. So how we extract the information from the PDF using the parser, and how we actually chunk this information. Yeah, obviously, we need to take a trade-off. So to create a Q&A dataset, so to create a dataset so we can run the evaluation, we needed to parse the documents. So we could not create a dataset with example answers and example questions that we could use. So in this case, we set, using MinerU, a PDF parsing library as a baseline. And then we will check additional PDF parsers against this baseline and the evaluation Q&A dataset that we assembled. In this case, the Q&A dataset was generated using an LLM. So we didn't rely on users to generate those questions. Yeah, Andrea, feel free.
OK, thank you, Ale. So let's dive into our experiment, what we really did. Remember that the key question is if and how the document processing strategies affect the quality of the generated answers. So that's our general setup of testing. We started with only 5 documents that are technical reports of around 100 pages each. And from those documents, using RAGAS, that is a well-known library for generating data sets for evaluating RAG frameworks, we generated a total of about 200 questions. And the key here is that we generated 3 different kinds of questions. We have single-op specific questions that are very narrow, very specific questions that require only just one chunk to be answered. Then we generated multi-hop specific questions. So also in this case, we have very narrow questions, but that requires combining multiple chunks to be answered. And then we have multi-hop abstract questions that are very generic questions that require a narrative answer that combines different chunks. And we run these documents using 4 parsers, 2 open source. We have PyMUPDF, that is one of the most known Python library to extract text from PDF files. Then we have PDFAct, that is a minor Java library, but that has very good performance. And then we also used 2 commercial services, 2 of the most known ones, that are LlamaParse and unstructured. And we combine those 4 parsers with the 2 most common approach of chunking, that are a rule-based one, so we simply split on specific characters, like new lines, and a semantic chunker that try to group together passages that are semantically similar between them. And in order to do that, we relied on a library that is called Chonky, and offers a very efficient implementation of that. And to assess the general quality of the answer, we still used RAGAS with an LLM-based matrix that try to capture the difference, the factual difference between the generated answer and the one in the dataset. So running all those combination of parser and chunkers, the first thing that we notice is a very different behavior in terms of chunk size. So in terms of number of tokens per chunk. And here we can see that rule-based chunking methods generally create more regular and bigger chunks, while semantic chunkings have a higher variability in terms of number per tokens. And it's also interesting that there are some convergence in behavior between different architecture and license, because we saw that PDFAct has a very similar behavior to unstructured, and likewise PyMUPDF to LlamaParse. But jumping into the real results, the matrix, the accuracy of the generated answer, we can see that there are some really interesting results, really interesting points here, because when considering multi-op abstract questions, we don't see much difference in terms of performance with different chunk size. But for multi-op specific questions, larger chunks really helps in creating much more precise answer, because the LLM needs to combine different chunks, so having more context really helps the final results. And on the other side, when using single hope-specific question, we saw that there is a slightly improving performance with shorter chunks because it helps having just the right amount of information. And in general, we saw that rule-based chunking in our settings almost always outperforms the semantic one. This is probably playing a little with all the parameters of semantic chunking. We could improve the performance a bit, but we took the two methods out of the box in their default setting, just for a first comparison. So here we saw that there is a difference in changing the parser and chunking methods between the different. We saw that changing parser and chunker changes the final performance of the RAG. But what we wanted to do is also to try to understand how can we use a set of grounded information to choose the right parser for our case. So we saw that there is there are different results based on the user questions, but the other important inputs in a RAG framework is the document type itself, it's the layout of the document itself. So we tried to go one step further, and we took this dataset, doclaynet, that consists of 8,000 pages of annotated text and layout across 6 different categories and 11 classes. And we ran this dataset among those 4 parsers. In particular, we implemented a proxy among those parsers that is open source. It's called Parsing, that helps to extract the text with those 4 parsers and format them in a same document format in order to simplify the comparison. And here we evaluated the ability of the parser to reconstruct the document in order to preserve the layout and the text in the starting pages, and we used some text similarity matrix to do that. And then we can see, for example, comparing the accuracy, the performance of the different parser among the different document categories, we can see that there is no one single parser that outperformed them all. But there are some differences. From this chart, we can see that unstructured perform better on reports and article-like documents, while PDF-Act or PyMoPDF did well on more layout-heavy content like patents and manuals. And if we go one step deeper, so if we consider a deeper categorization of the document, we can try to really extract some ground rules that should guide the process of selection. Just some example. If we are dealing with multi-columns documents with two or multi-columns document, you need a layout-aware parser, and it seems that unstructured does the job really well. Or if you are dealing with a small line spacing document with a lot of text compressed together, PDF-Act seems to preserve the reading order and not messing everything up. Or again, when processing documents with many form-like pages or a lot of difficult layouts to parse, PyMoPDF seems to be the right choice, and so on and so forth. So you can really extract some insights from this analysis. And the idea here is to extend those analyses to other datasets and other document categories to write up guidelines on how to choose the right parser. So the idea is to expand on that to really have a guidelines. So just to wrap it up, let's conclude. We saw that the document processing strategies have an impact on the RAG pipeline, and in particular, the choice of the document processing strategy should take into account the types of document and types of question. In particular, the document type should drive the parser choice, while the question type should mostly drive the chunking strategy. And finally, if you are implementing your RAG system and you see that the performance are not as well as expected, maybe don't immediately assume that the issue is with the model or with the retrieval, try to have a look at what you are feeding into the retrieval and how you are processing the document, because this can give a very different perspective and has a real impact on the final performance. And that's all. Thank you.
Okay, thank you. I think we already have one question in the room. So,
it's actually two questions. What did you do with headers?
Headers. Yeah, actually, in this case, we didn't strip it out, just because we wanted to have a plain comparison of everything. So there are a couple of parsers, like PDF-act, that tags the headings, the headers, the footer, and so on, to enable us eventually to strip it out. And you might also consider stripping them out. One thing that we discovered is that headings in the text, especially if the document is coming from an expert in his domain field, are very important because they carry information. So those needs to be preserved, and then you can eventually combine in the chunk and so forth. So that part, it's actually needs to be on a case-by-case somehow basis.
So the extended question would be, what about when you have a hierarchy of headings? Because you have a hierarchy of context, right?
Yeah, hierarchy, it's kind of, yeah, we are still exploring. I don't have a deep answer, but maybe Andrea has.
That's a really good question, because we didn't evaluate the layout tagging here. We just evaluated if the general structure is preserved. But we are also working on that, and there are some parsers, like unstructured, that creates a tree of your documents. And so for each chunk, you have the parents and the child. And in some sort of way, this works well with some title when they have a really well-defined font structure, also with bullet points that are hierarchical. So there are parsers that handle this. They are not perfect, of course, but they're starting to integrate those kind of information. So yeah, we just didn't evaluate them now.
thank you.
There's another question.
There's a question.
Thank you for the talk. I have a question about evaluation and of chunking. So the slide where you showed the differences between the different chunking methods. My question is, given the fact that if the one after, if I'm correct, the metric is from 0 to 1, right? So my curiosity is, given that pretty much all results are between 0.25 and 0.35, so they're quite close each other, have you compared the RAGA's evaluation with some like human-based evaluation to see if it aligns, for example, if you see greater differences? Because I think you were using like 5 documents and some 100 queries, so nothing like crazy big. So yeah, I have just this curiosity.
Yeah, I think it's for you, Andrea.
Thank you for the question. We tested with many metrics. We started with more text similarity metrics that didn't give much information, like rouge score, blue score. Then we went into those metrics. We are actually trying to evaluate those with set users, but we didn't do that yet because it's difficult to make a user giving you also just a thumbs up or a thumbs down. It requires a lot of effort, and there are a lot of people and a lot of willing to do. So we are trying to do that, but based on the state of art, these metrics should really align to what generally people want from a metric. This is the state of the art. Basically, everyone doing RAG use metrics like that on Ragas, on framework like that. So it's very difficult to evaluate those kind of stuff. You are absolutely right when you say that you need some user that confirm your results. But yeah, we didn't do that. We still didn't do that. Yes.
Thank you. So that's the end of this. Oh, maybe just one question, very quick.
I'll be very quick. So I was wondering, how can you create a evaluation question that requires multiple chunks to answer? What's the technique behind that?
Here we relied also for that on Ragas, and Ragas tried to build a knowledge graph of your chunks, and so using always LLMs to infer an answer that requires multiple steps between different chunks that are connected together in the knowledge graph to be answered. So the key idea is to connect together chunks with some sort of relation and extract from chunks that are connected by some sort of relation a questions that so needs all of them to be answered. The basics is always LLMs also for that.
Okay, thank you very much, Andrea and Alessio. So I think we can congratulate them on their first talk here in Berlin. And feel free to come talk to them if you have any more questions. Thank you.